Good afternoon to all. Today we are going to start our next chapter, that is multivariable differential calculus. Already we had discussion on this differentiation. Even though I am going to start this chapter once again. So here so how we are using that partial differentiation and where to use that partial differentiation. Okay. So as we know that area of a rectangle, just we have discussed that area of rectangle depends upon the length and the breadth. Hence area is function of two variables. Area is function of two variables. Okay. Means that is its length and its breadth. Now, if you are taking that volume of a cube, that depends upon its length, breadth and height. Thus, volume is function of three variables. That is f of, look at this, volume we are taking as V. V is depend upon length, breadth and height. So here volume is function in L, B, H. These are the three variables. What about area? Area depends upon length and breadth. Okay, there are two variables. Okay, so here if you are taking that A is equal to f of LB, that means Z is equal to f of xy. Z is equal to f of xy is called a function of two variables. Is called a function of two variables. Okay. आता याच्यामधले डिपेंडेंट आणि इंडिपेंडेंट कोणते व्हेरिएबल्स असतील? x and y are called as independent variables and z is called as dependent variable. Why it is known as independent? Anyone can tell me that? Why x and y are called as independent and here z is called as a dependent variable? Z is a dependent variable and x and y, these are the independent variable. Means z is depending upon the value of x and y. Z is depend upon the value of x and y. Means suppose I am taking that z is equal to 2x square. Okay, z is function in x. Okay, so if you are taking derivative of this z, dou z by dou x, partial derivative of z, that is dou z by dou x. So it will be 4x, isn't it? It is 4x. If we are changing the value of x, obviously we are getting the different values of this z. Means here x is independent and z is a dependent variable. Everyone understood this?
Yes, ma'am.
Dependent variable and independent variable. Okay. Now partial differential coefficient, means here multivariable differential calculus is known as partial differentiation. Okay. If the function z look at this. The partial differential coefficient of f of xy with respect to x is the ordinary differential coefficient of f of xy when y is regarded as a constant. आता या ठिकाणी थोडंसं हाय लेवलचं आपल्याला सेंटेन्स घेतलेले आहेत. पण आपल्याला एक लक्षात ठेवायचंय, पार्शियल डेरिव्हेटिव्ह घेतोय ज्यावेळेस आपण दोन फंक्शन्स असतील, पार्शियल डेरिव्हेटिव्ह आपण घेतोय तर त्याच्यामधला एक जो फंक्शन आहे, एक जो व्हेरिएबल आहे, त्या फंक्शन मधला एक व्हेरिएबल जो आहे तो कॉन्स्टंट कन्सिडर करतोय. म्हणजे ऍज वी हॅव z इज इक्वल टू x प्लस y. z is equal to x plus y, or z is equal to x into y. Now we are taking partial derivative of this z. It will be derivative with respect to x is equal to 1, and this y is constant, therefore it is plus 0. And when we are taking derivative of this z with respect to y, that time x will be constant. In same way, z is equal to x into y. So here one term, while we are taking the derivative of this x, derivative of this z with respect to x, at that time this y will be constant, means here dou z by dou x is equal to y, and dou z by dou y is equal to x. Means one term or one that variable will be constant. Okay. Then after that, here we are denoting that partial derivative with dou f. Means here f is function in x and y, so it can be put as dou f by dou x or dou f by dou y. Whatever that functions are, variables are there, according to that variables we can take that derivatives in this notation. Or this can be, this dou f by dou x, it can be put as fx. This will be fy. Now I am taking the derivative of this derivative, means it will be dou by dou x of dou f by dou x. म्हणजे या ठिकाणी आपण सेकंड ऑर्डर डेरिव्हेटिव्ह घेतोय, सो इट विल बी dou 2f by dou x square. Similarly, I am taking derivative of this given function with respect to y. फंक्शन इथे डेरिव्हेटिव्ह कोणता आहे, dou f by dou x. आता with respect to y घेते, so it can be put as dou 2f by dou y dou x. Got it? Then if I am taking derivative of y, पहिल्यांदा dou y by dou x आपला आहे इथं, dou z dou f by dou y. Now I am taking that dou f by dou y. Again I am taking derivative of this function with respect to x. It will be dou 2f by dou x dou y. Dou 2f by dou x dou y. Now if I am taking derivative of this function with respect to y only, so dou by dou y of dou f by dou y is equal to, it is dou 2f by dou y square. या ठिकाणी f च्या ऐवजी z असू शकतो, u असू शकतो, किंवा आणखी दुसरा व्हेरिएबल असू शकतोय. ओके. आता मी सपोज याला z इज इक्वल टू f ऑफ x y घेतलं तर इथं असेल dou z बाय dou x. जर या ठिकाणी u घेतला असेल तर dou u बाय dou x असेल. ओके. व्हेरिएबल्स मे बी चेंज, बट दैट प्रोसेस इज रिमेनिंग सेम. Now after this, फर्स्ट ऑर्डर झाला, सेकंड ऑर्डर झाला इथं. सिंपल एक्झाम्पल. हा,
स्लाइड चेंज केली आहे का मॅडम तुम्ही?
स्लाइड नाही चेंज केलेली आहे, ती स्लाइड बस हे केलेलं आहे. दिसत नाहीये का तुम्हाला?
नाही मॅम.
जस्ट अ मिनिट. हा हा, लिहिलेलं दिसलं नाही का तुम्हाला?
दिसलं.
आता दिसतं?
Yes.
Yes, ma'am.
Okay. In this chapter, in multivariable differential calculus, that is partial differentiation, in this chapter, we are going to study partial derivatives of first and higher order, variable to be treated as constant, total derivatives, then multivariable differentiation of composite function, then homogeneous function and Euler's theorem. Okay. So we are going to start some simple with simple examples. Just a minute. बरोबर, काही एक्झाम्पल्स आपण सॉल्व्ह केलेले आहेत. हे हाय लेवलचे एक्झाम्पल्स आहेत सगळे. Once again, I will repeat that all examples which we have taken that. Okay, on that day. Let me tell that derivative of find out partial derivative of given function with respect to x and with respect to y, where z is equal to sine of x plus y. As we are denoting derivative of partial derivative of z, that is dou z with respect to x, it is equal to derivative of this function, that is cos of x plus y. If we are taking derivative of this z with respect to y, dou z by dou y is equal to, again it will be cos of x plus y. Now if we are taking that z is equal to sine inverse of x by y, sine inverse of x by y. Yes, derivative of this function with respect to x and with respect to y. So look at this, dou z by dou x is equal to derivative of sine inverse of x upon y. Just consider this sine inverse of theta. So 1 upon
the root
square root of
square
1
of
minus x by y
square.
bracket square. Now simplify this. So 1 divided by square root of, look at this, 1 minus x square upon y square. So it will be y square minus x square divided by y square. Therefore, dou z by dou x is equal to y divided by square root of y square minus x square. In same way, we are taking derivative of this z with respect to y. It is equal to 1 upon square root of 1 minus, just a minute, look at this. Here we missed one term, 1 upon square root of 1 minus x by y is square into derivative of x upon y with respect to x, that is 1 upon y.
Yes, ma'am.
Yes, so into 1 upon y. So here it will be cancelled. Into 1 upon y, it is equal to 1 divided by square root of y square minus x square. So here again x square y square into derivative of x upon y with respect to y. It is minus x upon y square, which is equal to y divided by square root of y square minus x square into minus x upon y square. So 1 y will cancel. So minus x upon y into 1 divided by square root of y square minus x square. This will be the correct answer. Is it correct?
Yes.
Now next, if z is equal to tan inverse of x upon y, then what is the derivative of this function with respect to x? Dou z by dou x is equal to derivative of tan inverse of x, that is 1 upon 1 plus x square divided by y square into derivative of x upon y with respect to x, it gives 1 divided by y, which is equal to 1 upon y square plus x square divided by y square into 1 upon y. So it will be y square upon y. Okay. So here we are getting y upon x square plus y square. Now taking derivative of this function with respect to y. So it is dou z by dou y is equal to 1 divided by 1 plus x square divided by y square into derivative of x upon y with respect to y. It is minus x constant, derivative of 1 upon y minus 1 upon y square, which is equal to y square divided by x square plus y square, that आपण LCM घेतो, into minus x upon y square, which is equal to y square will cancel, and here the answer is minus x upon x square plus y square. Okay, this is the partial derivative of z with respect to x and with respect to y. Okay, now after this, higher order partial derivatives. How to write that higher order partial derivatives? Of u is equal to f of x y z. U is equal to f of x y z. Just I am taking derivative of this function with respect to x. It will be dou u by dou x. Okay. So first I am taking that dou u by dou x. Then we can write that dou u by dou y, and derivative of u with respect to z, that is dou u by dou z. Now I am taking derivative of this function with respect to x again. Just we have discussed dou by dou x of dou u by dou x, and it can be represent or it can be write with dou 2u by dou x square. Okay. Next, dou by dou y of dou u by dou x. It will be dou 2u by dou y dou x. Then dou by dou y of dou u by dou y. It is equal to dou 2u by dou y square. Now I am taking derivative of dou u by dou y with respect to x. Dou u by dou y, its derivative with respect to x, it can be write as dou 2u by dou x dou y. In short, look at this. In short, this can be put as fxx, or sometimes it is in u, therefore it will be uxx. What is the meaning of uxx? Second order derivative of u with respect to x. Okay. Now here, this can be put as fxy, derivative of fx with respect to y. Got it? Here it will be fyy, derivative of fy with respect to y, or it can be put as uyy. शॉर्टकट मध्ये असं लिहू शकतात. काही वेळेस क्वेश्चन मध्ये ज्यावेळेस तुम्ही होमोजिनियस फंक्शन शिकताय त्याच्यामध्ये असे शॉर्टकट्सचे एक्झाम्पल्स आहेत. ओके. नाउ दिस कॅन बी पुट एज uyx, derivative of y uy with respect to x. Then I am taking that derivative of this dou u by dou z with respect to x. Dou u by dou z, it is equal to dou 2u by dou x dou z. Okay. Now if I am taking derivative of this function dou 2u by dou x dou z with respect to dou y, with respect to y, so it will be dou cube u by dou y dou x dou z. सिक्वेन्स लक्षात ठेवायचा याच्यामध्ये. पहिल्यांदा काय केलं होतं आपण, डेरिव्हेटिव्ह ऑफ u डो u बाय डो z विथ रिस्पेक्ट टू x घेतला. So it is dou 2u by dou x dou z. Again I am taking derivative of this function with respect to y. So here it will be dou cube u by dou y dou x dou z. Everyone understood this?
Yes, ma'am.
Okay. आता नेक्स्ट आपण असं घेऊयात इथं डो बाय डो एक्स ऑफ डो टू यू बाय डो वाय डो झेड. आता याचा डेरिव्हेटिव्ह घ्यायचंय मला परत विथ रिस्पेक्ट टू एक्स. सो इट कॅन बी डो क्यूब यू बाय डो एक्स डो वाय डो झेड. Everyone understood?
Yes, ma'am.
Yes, ma'am.
Okay. Now I am taking that partial derivative of higher order if they exist can be obtained from partial derivatives of given function. Okay, so look at this. I'm taking that first example. If u is equal to x cube y plus xy cube, then find dou 2u by dou x square and dou 2u by dou y square. So look at this. By using the higher order derivative of given function, here u is given, u is equal to x cube y plus xy cube, then partial derivative of this function. First आता इथे बघा dou 2u by dou x square आहे, म्हणजे दिलेल्या फंक्शनचं दोन वेळेस विथ रिस्पेक्ट टू x डेरिव्हेटिव्ह घ्यायचे. परत dou 2u by dou y square आहे, means again we are taking derivative of given function with respect to y two times. So first I am taking that dou u by dou x. Dou u by dou x is equal to partial derivative of given function with respect to x, 3x square y plus y cube.
Y cube.
Again differentiate this function with respect to x. It is dou by dou x of dou u by dou x is equal to, it is dou 2u by dou x square is equal to 6xy plus 0, because y is constant. Now taking derivative of this u with respect to y, so it is dou u by dou y. Dou u by dou y is equal to x cube plus 3xy square. And now again we are differentiating this function with respect to y. So it gives dou 2u by dou y square, and which is equal to x cube, that is constant, plus 3xy square, it is 6xy. So here we are getting that answer 6xy. Okay. Now next, second example. If u is equal to e raised to x into y square, then find dou u by dou x and then find dou 2u by dou x square and dou 2u by dou y square. Okay, so let us see. Given function u, e raised to x into y square, derivative of this function with respect to x, it gives e raised to x into y square, and again we are differentiating this function with respect to x. It is dou u by dou x is equal to e raised to x into y square. In same way, we are taking derivative of that given function with respect to y is equal to e raised to x constant, derivative of y square, it is 2y. And if we are differentiating this function again with respect to y, it gives dou 2 u by dou y square. So it is 2 into e raised to x. Is it okay?
Yes, ma'am.
Suppose I want to take the derivative of given function dou 2u by dou y dou x. Means here dou by dou y of dou u by dou x is equal to derivative of given function with respect to y. So dou u by dou x काय आहे? E raised to x into y square. Now I am taking derivative of this function with respect to x. Sorry, with respect to y. So e raised to x constant, derivative of y square, that is 2y. So 2 into e raised to x into y. ठीक आहे, म्हणजे इथं पहिल्यांदा दिलेलं फंक्शन असणार आहे, दिलेलं डेरिव्हेटिव्ह असेल विथ रिस्पेक्ट टू वाय असेल, विथ रिस्पेक्ट टू झेड असेल, विथ रिस्पेक्ट टू जे काही असतील टर्म्स त्या ठिकाणी तिथं तुम्हाला त्या सिक्वेन्स मध्ये तुम्हाला डेरिव्हेटिव्ह घ्यायचे. इज इट क्लिअर टू ऑल?
Yes, ma'am.
Okay. Now next example. Almost simple examples we have taken.
Excuse me, madam. I am Yashpal Khedkar.
Yes, sir.
Waiting
Yes,
for
sir.
next lecture.
Just a minute, sir.
Yes, please.
Now next example. If u is equal to e raised to xyz, if u is equal to e raised to xyz, then find dou cube u divided by dou x, dou y, dou z. So how we are taking derivative of this given function? First, u is given that is e raised to xyz. Now according to this sequence, first differentiate with respect to z, then with respect to y, and then with respect to x. So taking derivative of this function with respect to z first, it is e raised to xyz into xy. Okay. Now differentiating this function with respect to y, it is dou by dou y of dou u by dou z, which is equal to, once again I am writing with that sequence, dou by dou y for the function x into y into e raised to xy z. Okay, applying that u into v rule. First, derivative of the given function x into y into e raised to xyz. So first e raised to xyz into derivative of e raised to xyz with respect to y, it is xz. Okay, into xy as it is, plus derivative of xy, e raised to xyz as it is, derivative of x into y with respect to y, it is simply x. Now by getting simplification, if we are taking that e raised to xyz as a constant, common term, in bracket x square y z plus x. Okay.
मॅम लॉग यूज केलं तरी पण होते ना?
काय?
लॉग
कुठला लॉग?
फर्स्ट ह्याच्यासाठी लॉग यूज केले.
कुठे लॉग म्हणजे मला सांगताय तुम्ही थोडंसं इथं कसं सॉल्व करायचं?
u is equals to
dou 2u by dou y dou z. Again I am taking derivative of this function with respect to x is equal to, please, we have x into e raised to xyz, plus e raised to xyz into x square yz. Tell me the derivative.
E raised to xyz into yz into x square yz plus x.
आता पहिल्यांदा e raised to xyz तसंच ठेवते का मी?
चालेल मॅम.
e raised to xyz into ब्रॅकेटचा डेरिव्हेटिव्ह घेऊयात with respect to x. So it is 2xyz plus x. Sorry, plus 1. It is plus 1. The next plus this bracket keeping as it is x square yz plus x into derivative of this function e raised to xyz. So it is e raised to xyz into yz. Simplify करा. Common term घेऊ शकतो आपण e raised to xyz in bracket 1 plus 2xyz plus multiplying this yz with this bracket. So it will be x square y square z square plus xyz, which is equal to, equating the same terms, e raised to xyz in bracket 1 plus 3xyz plus x square y square z square. This is the answer, that is dou cube u by dou x dou y dou z. ठीक है? Now next example. Note down. If u is equal to x raised to y, look at this, if u is equal to x raised to y, then show that dou cube u by dou x square into dou y is equal to dou cube u by dou x dou y dou x. ओके, आता पहिल्यांदा कोणतरी एक कन्सिडर करा. LHS is equal to, here u is given x raised to y. Okay, now LHS left hand side, that is equal to, we have dou cube u by dou x square dou y, isn't it? Means here we are taking derivative of given function, that is dou 2u by dou x dou y. पहिल्यांदा आपण dou u by dou y काढायला पाहिजे इथं. So dou u by dou y is equal to derivative of x raised to y with respect to y, keeping x constant. So it is
x raised to y log x.
X raised to y
Log x.
into log x. Now again differentiating this function with respect to x. So it gives dou 2u by dou x dou y is equal to, taking derivative of x raised to y into log x with respect to x. Y constant राहणार इथे आता तुमचा. So y into x raised to
Y
minus 1 into log x plus x raised to y divided by x, or it can be write as
x raised to
y into x raised to y minus 1 into log x plus x raised to y minus 1. From denominator x raised to 1 we are taking in numerator, and by using law of indices it will be x raised to y minus 1. Next, again here you can take that x raised to y minus as a common term, and in bracket we get y into log x plus 1. ठीक है. Next, derivative of this function with respect to x again. So dou by dou x of dou 2u by dou x dou y is equal to means
Y
here
minus
derivative of given function, that is x raised to y minus 1 in bracket y into log x plus 1 याचा डेरिव्हेटिव्ह विथ रिस्पेक्ट टू x घेतोय आपण, which is equal to, tell me that.
y minus 1 x y minus 2 x raised to y minus 2.
विथ रिस्पेक्ट टू x म्हणजे y कॉन्स्टंट राहिला, या ठिकाणी u into v रूल अप्लाय करावा लागेल तुम्हाला.
Yes.
एक एक फंक्शनचं घ्या.
सेकंड कॉन्स्टंट आणि फर्स्टचं डेरिव्हेटिव्ह.
तर बघा पहिल्यांदा x रेज टू y मायनस 1 कॉन्स्टंट ठेवला ब्रॅकेट मध्ये y into log x, y divided by x plus 0 plus y into log x, that is 1 plus y log x constant into derivative of x raised to y minus 1, that is y minus 1 into y minus 1 into x raised to y minus 2, which is equal to, आता इथलं सुद्धा तुम्हाला x raised to y minus 2 मिळेल into y, परत इथला x raised to y minus 2 कॉन्स्टंट कॉमन घेतला तर ब्रॅकेट मध्ये काय राहील y plus 1 plus इथं असं असेल 1 plus y log x into y minus 1. ठीक आहे.
येस मॅम.
x raised to y minus 2 कॉमन घेतला म्हणजे या ठिकाणी आपल्याला काय मिळालं, dou cube u by dou x square dou y. Now consider that RHS. So by going RHS,
मॅम ते वरच्या स्टेप समजले अजून.
सॉरी
ते
आवाज
वरच्या
येत नाही
स्टेप
तुमचा,
समजले
काय
नाही.
म्हणताय,
वरच्या स्टेप समजलं नाही मॅम.
कुठली, ही का,
ते हो मॅम, एक्स रेस टू वाय मायनस.
इथलं का,
हा मॅम सेकंड वाला.
हा इथे बघा आता u into v रूल अप्लाय करतो इथं, कारण दोन्ही टर्म मध्ये x व्हेरिएबल आहे. मग आता u into v रूल अप्लाय केल्यानंतर एक टर्म तसंच ठेवतो, दुसऱ्या टर्मचा डेरिव्हेटिव्ह घेतोय. मग पहिल्यांदा मी x raised to y minus 1 कॉन्स्टंट तसंच ठेवला, y into log x plus 1 याचा डेरिव्हेटिव्ह घेतोय. y कॉन्स्टंट, कारण x सोबत आपण डेरिव्हेटिव्ह घेतोय, y कॉन्स्टंट ठेवतोय, log x चा डेरिव्हेटिव्ह 1 upon x, सो y upon x झाला, प्लस हा ब्रॅकेट आपण कॉन्स्टंट ठेवला 1 plus y into log x into derivative of x raised to y minus 1, it will be y minus 1 into x raised to y minus 2. आता इथं x raised to y minus 1 into y upon x आहे, हा x मी न्यूमरेटर मध्ये घेतला तर raised to minus 1 होईल, सो y minus 1 it is y minus 2. मग ह्या दोन्ही मधनं x raised to y minus 2 कॉमन घेतला आणि जे काही टर्म्स राहतात ते आपण एका ब्रॅकेट मध्ये लिहिले.
येस मॅम.
Now go for next, that is right hand side. Dou x dou y dou x. आता याच्यामध्ये पहिल्यांदा विथ रिस्पेक्ट टू x घेतोय, सो कन्सिडर dou u by dou x is equal to dou u by dou x is equal to derivative of given function with respect to x, y into x raised to y minus 1. Again differentiating this dou u by dou x with respect to y, which is equal to dou 2u by dou y dou x is equal to with respect to y घेतोय, so y into x raised to y minus 1 याचा डेरिव्हेटिव्ह
X raised to as it is.
y as it is x raised to y minus 1
into log x
log x plus x
x
raised to
y minus
y minus 1. याच्यातनं x raised to y minus 1 कॉमन काढा. y minus 1 ब्रॅकेट मध्ये काय राहील 1 plus y log x. ठीक आहे. आता परत त्याचा डेरिव्हेटिव्ह घेतोय. सो dou 2 u by dou y dou x. Again we are taking partial differentiation with respect to x. Here it is dou by dou x of x raised to y minus 1 into in bracket 1 plus y log x. ठीक आहे. बघा इथं ही टर्म चेक करा. x raised to y minus 1 into 1 plus y log x. याचा डेरिव्हेटिव्ह परत एकदा घेतोय आपण. So here applying that u into v rule. So putting x raised to y minus 1 constant, taking derivative of 1 plus y log x, that is 0 plus y into log x. So y upon x plus x raised to y minus 1 constant, 1 plus y into log x constant. This bracket we are keeping as it is 1 plus y log x into derivative of x raised to y minus 1 with respect to x. So it is y minus 1 into x raised to y minus 2, which is equal to x raised to y minus 1 divided by x. It is y minus 2 into y plus 1 plus y into log x into y minus 1 into x raised to y minus 2. Now we are taking that x raised to y minus 2 as a common term, and in bracket we have y plus 1 plus y log x into y minus 1. Now find out whether LHS and RHS are same. बघा इथं this is LHS and here it is RHS. Therefore we can say that LHS is equal to RHS. Okay.
Yes, madam.
yes ma'am
ठीक आहे. पुढचं एक एक्झाम्पल घेऊयात आपण. Next one. If u is equal to f of x plus ay, f of x plus ay plus phi of x minus ay, then prove that dou 2u by dou y square is equal to a square into dou 2u by dou x square. Okay. Now first of all we are taking the given function, that is u. Here u is equal to f of x plus ay plus phi of x minus ay. Now taking derivative of this function with respect to x first. With respect to x. So dou u by dou x is equal to dou u by dou x is equal to derivative of given function f of x plus ay plus phi of x minus ay. So here f of x plus ay, derivative of this function
f dash x
f
plus
dash of x plus ay into taking derivative of this bracket with respect to x.
1 plus
So it will be
1.
1. Okay, plus phi dash of x minus ay into 1. Again differentiating this function with respect to x. So it is dou 2u by dou x square is equal to f double dash of x plus ay into 1 plus phi double dash of x minus ay into 1. Okay. Now, taking derivative of that u with respect to y. Dou u by dou y is equal to f of x plus ay, derivative of this function, that is f dash of x plus ay into derivative of this x plus ay with respect to y, it is a, plus phi dash of x minus ay into minus a, which is equal to a into f dash of x plus ay minus a into, by taking that a as a common term, phi dash of x minus ay. Okay, again differentiating this dou u by dou y with respect to y. So it gives dou 2u by dou y square, which is equal to a constant, taking derivative of this bracket, that is f double dash of x plus ay into a minus phi double dash of x minus ay into minus a. Again here we can take that a as a common term, a into a, it is a square, and in bracket we have the term f double dash of x plus ay minus into minus becomes plus phi double dash of x minus ay. So look at this, a square, and for this bracket we can write dou 2u by dou x square. Hence the proof. समजलं सगळ्यांना?
Yes, ma'am.
Yes, ma'am.
yes ma'am.
Now after this, we have taken that composite function. How we are defining that composite function? That is differentiation of function. That is called as a composite function. So let z is equal to f of u and u is equal to phi of xy, so that z is called as function of phi. म्हणजे या ठिकाणी z is function in u and u is function in x and y. Okay, so here it is function of function, or it is called as a composite function. Okay, क्लास मध्ये सॉल्व कर म्हणजे दाखवलं होतं तुम्हाला z is function in like this. Z is function in x and y Suppose x and y are functions in u and v, then we can say that z is function of u and v. That is, z is composite function of u and v. These are the function of function. Okay. तर या ठिकाणी आपण घेऊयात परत. Let u is equal to f of x by z and x is equal to f1 of t, y is equal to f2 of t, then and z is equal to f3 of t. Then by using total derivative, du by dt is equal to total derivative. Total derivative, how we are writing that? Du by dou x into dx by dt plus du by dou y into dy by dt plus du by dou z into dz by dt by using total derivative. इथं लिहिते बघा, इथं u is function in x, y, z, where x, y, z these are functions in t. मग आता मला याचा डेरिव्हेटिव्ह u चा डेरिव्हेटिव्ह विथ रिस्पेक्ट टू t घ्यायचंय. म्हणजे त्या ठिकाणी काय आला, du by dt. ओके, टोटल डेरिव्हेटिव्ह घेतोय आपण. सो du by dt. मग du by dt घेताना काय करणार आपण, ux याचा डेरिव्हेटिव्ह, इथं आपण काय करणार, पार्शियल डेरिव्हेटिव्ह ऑफ दिस फंक्शन, आणि या ठिकाणी कंप्लीट डेरिव्हेटिव्ह. परत du by dou y dy by dt, du by dou z dz by dt. हे थोडंसं स्ट्रक्चर आहे, तर थोडं समजून घेतलात ना तुम्ही, तर तुम्हाला डेरिव्हेटिव्ह घ्यायला खूप इझी जाईल. कोणते डेरिव्हेटिव्ह असतील ते इझी वे मध्ये तुम्ही सॉर्ट आउट करू शकता. नाउ we can say that du by dt is called as total differential coefficient. Total differential coefficient of z. आता या ठिकाणी u असल्यामुळे इथं आपण u कन्सिडर करतो ऑफ u, and this rule is called as, have you learned it? कोणता रूल म्हणतो आपण? Rule is called as
chain.
Yes, it is chain rule.
Chain.
It is called as a chain rule. ओके, टू व्हेरिएबल्स मध्ये तुम्ही शिकलेला असाल, ज्यावेळेस आपण टू व्हेरिएबल मध्ये घेतोय त्या ठिकाणी कसं घेतोय बघा, इथं when just we are taking with x and y in two variable, if u is equal to f of xy and x is equal to f of t and y also f of t, at that time we are taking that du by dt is equal to dou u by dou x into dx by dt plus dou u by dou y into dy by dt, and completely it can write as du is equal to dou u by dou x into dx plus dou u by dou y into dy. So here it is called as a chain rule in two variables, and here du by dt or this du is known as total differential coefficient. This is called as a total differential coefficient. Okay. Let me check your attendance. Roll number 1, 2, 3, 4, 5. 5 absent. Six, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 20 absent, 21, 22, 23, 24, 25, 26, 27, 28. Number 5. 2. Roll number 38. Roll number 38. Here we are going to wind up this session. We will meet soon in next lecture. Thank you all of you.